Hello there, welcome back. It's good to see you again. In this lecture, we'll be talking about how computers understand and communicate with different types of characters. As you saw in the previous lecture, we encountered a problem with printing characters in the terminal. Specifically, our application was unable to recognize these characters and showed question marks instead. Okay, what might be the reason behind this problem and why we saw these question marks instead of the expected character? As you know, computers operate using a language called binary code, made up of only zeros and ones, and they cannot understand characters or textual data without extra help. To make it possible for computers to handle textual data, character encoding was created as a standard way to convert characters into binary format for storage, processing, and displaying them. Character encoding used encoding schemes to convert characters into a binary format. Each encoding scheme defines the specific rules to convert each character into a Unicode point that computers can understand. One of these encoding schemes is ASCII. ASCII can represent 128 characters using unique 7-bit binary codes. It includes Latin-based letters, numbers, and basic symbols, and it mainly used in English language context. Alright, let's demonstrate how computers can understand textual data by encoding and decoding characters with the help of encoding schemes like ASCII. To illustrate this process, let's imagine that we've typed the uppercase S using our keyboard. After receiving input from the keyboard, the computer looks up the corresponding ASCII code point for that character. In this case, the uppercase S maps to decimal value 83. After converting the character into 83, the computer stores this value as a binary sequence in its memory. What we've just shown you is an example of how computers encode textual data using ASCII rules. On the other hand, to display our previously stored uppercase S on the screen, the computer reads that information directly from its memory. After reading the binary data, the computer interprets it as an ASCII code point, in this case 83 in the decimal. Then, using the ASCII table, the computer looks up the corresponding character for the ASCII code point, which in this case is the uppercase S. Next, it displays the character on the screen. What we've just said is an example of how computers decode textual data using ASCII rules. Alright, so far so good. Now we have a computer named System A that has the ASCII encoding scheme. But suppose we need to display Japanese characters on a computer named System B. In this case, since ASCII was designed specifically for English language only, so it cannot find the Japanese characters on its own table, and because of that, System B cannot be able to display Japanese characters correctly. In order to properly support Japanese characters on this system, we should consider using an alternative encoding scheme such as ShiftJIS. Now, the Japanese characters are recognizable for System B. As you can see, the decoding process is the same as we previously explained, and thanks to the ShiftJIS encoding scheme, we can correctly see the Japanese characters on the screen. In the same way, just like how we use ShiftJIS for Japanese characters on System B, other languages may need their own unique encoding schemes to be displayed their characters correctly. In total, using different encoding schemes on different systems can cause communication problems if they don't share the same standard. Alright, let's illustrate to you why using different encoding standards can be a problem. Suppose System B sends a message containing Japanese characters like this to System A. After receiving the message, System A cannot be able to display Japanese characters correctly because it uses ASCII encoding which cannot interpret these characters. As you can see, this example highlights why having a standard way of representing textual data such as Unicode is essential for avoiding issues across different systems with different encoding schemes. Alright, what exactly is Unicode and how does it represent textual data? Let's explore that next. Unicode is a character encoding standard that assigns a unique number called a code point to each character in a wide range of scripts and languages. These are some unique code points that represent their corresponding character. Unicode provides some encoding schemes that allow different systems to store, process, and display textual data in a consistent way. There are several popular encoding schemes used to represent Unicode characters in binary format, including UTF-8 and UTF-16. UTF-8 is a widely used Unicode scheme that uses 1 to 4 bytes to represent characters. This means that it can represent most languages and scripts, including those with non-Latin alphabets such as Japanese, Persian, Chinese, etc. In simple words, UTF-8 makes sure that you can store, process, and display textual data from any language or script using minimal space without losing information. UTF-16 is another Unicode scheme using 2 or 4 bytes per character and supports all characters like UTF-8 but with different byte orderings. Alright, now suppose both of these systems use UTF-8 to interpret textual data. In this case, when System B sends the Japanese message to System A, this system would be able to properly interpret and display the Japanese characters. Okay, let's return to our console application and resolve the issue we encountered in the previous lecture. The first thing you should know is that, by default, the console class uses the OS encoding scheme to display characters in the terminal. And since our operating system encoding does not support this character, we see question marks in the terminal. So, based on our previous discussion about character encoding, we now understand that we can resolve this issue by changing the encoding scheme of the console class to UTF-8. So, we go for console.outputEncoding equals encoding.utf8. As you can see, the compiler doesn't recognize the encoding class. To get rid of this error and access to encoding class, we have to use using keyword followed by its namespace name, which is system.text. Now, after changing the encoding scheme to UTF-8, let's run the application and see what happens. As you can see, the console class correctly interprets that character and displays it in the terminal. It happens thanks to changing the output encoding scheme to UTF-8. Okay, done. We'll see you in the next lecture.